This is the voice of Ed Williams, an eager simulation user over the past 35 years. We have a good pedigree here. Historically, I worked at Ford doing simulation from the late 1970s until 2001. Then I retired for 1 week and got bored, so I came here. Simulation is one of many of the very powerful tools of industrial engineering for improvement that we use here. And this is what it does. You build a model on the computer of a real system, manufacturing, or it could be healthcare delivery or warehousing. Simulation has very broad applicability. You conduct experiments with the model and evaluate what might be done to improve the system. It might be a system that already exists and needs improvement or expansion, or it might be a system that's under design. And since simulation can do these things, particularly including the handling of random variation, it's a wonderful way to assess potential improvements in the real system without having to disturb or shut it down or disrupt it. You're doing your investigation on the computer. And simulation software nowadays lets you build an animation almost automatically. The incremental effort is nearly zero. That makes the results easier to visualize, understand, and communicate. So these are some very good reasons to simulate. You can test before implementation. For example, designing a new factory. Would you rather discover that you need to add another machine or knock out a wall and change things around on the computer or in concrete on the factory floor? Well, if you test before implementing, it's a lot quicker, a lot cheaper, and a lot less disruptive. And particularly for manufacturing operations and for service industries also, simulation is a very good way to investigate with all the power that statistical analysis provides of doing all these different things to reduce costs. And many of these approaches to reducing costs are synergistic, where 2 or 3 improvements suggested by a simulation analysis are far more powerful than any one of them taken individually. So for simulation models can be built at 30,000 feet, you might call this one, or 20,000 feet, and you get right down to the level of detail. In fact, it's often a good idea to begin here at the enterprise level, and then, as a biologist might say, keep turning up the magnifying power on the microscope as you dig deeper into more detailed methods of improvement. And which one of these you use first is strongly dependent on the objectives of the analysis. Here's our simulation methodology. In this pie chart, you begin at 3 o'clock, if this were a clock face, and you go counterclockwise. This is a big piece. In fact, at other dates, we have a webinar just on this, collecting data. And this is an even bigger piece, experimenting and analyzing results. We have a separate webinar on detail there. For the moment, it's useful to visualize that from 3 o'clock back over here to 9 o'clock, you are investing time and money as the client in building a simulation model and making sure it's correct, verify and validate. Coming back around here, you are reaping return on your investment. You're finding out valuable information at low cost, low disruption, short time on how to improve the process you're designing, or indeed how to improve the process you already have operational but that needs improvement or expansion. And these ideas fit in very well with the famous Goldratt 5-step process. Simulation follows these ideas. Now, coming in for a bit more detail about Witness. Witness is one of many software simulation tools that we use here at PMC. Here at PMC, we use 8 or 10 of them. I'm well acquainted, expert modeler in 5 of them, Witness being one of them. And here's some appeals. This first list shows the versatility of simulation. Manufacturing, heavy manufacturing, computer manufacturing, healthcare delivery, and there's a wide variety likewise of companies. And Witness is particularly useful many times in both manufacturing and warehousing, and not just one or the other, but the whole supply chain from manufacturing to warehouse to distribution. And looking here, you see some of the many industries that have used Witness. And this slide, we'll pause a moment, give you a chance to read it. And later this slide will be available along with the whole slide deck on request or on YouTube. But the details here help convince people of the hard benefits that simulation, and in these cases in particular Witness, was able to provide that go straight to the bottom line. So these are case studies. Lanner is the Witness software provider, and we're in partnership with them. And here are some of our own case studies likewise that we've done here at PMC. And the details on this slide likewise give you an enticing preview of how helpful simulation can be. And simulation is especially helpful when it's used not in isolation, but in concert with the other methods of industrial engineering that we listed previously, like Six Sigma, 5S, value stream mapping, and so forth. So simulation improvements gained using Witness have a good long ancestry and pedigree. Now, conceptually, to think of how would you get started using Witness and understanding what goes on inside a Witness model, there's these little tidbits. For example, that's push and that's pull. Witness is very good at both, pull systems, push systems, and this gets right into how does Witness work. Well, in the Witness world concept, to build a simulation model, parts move through a system. The parts might be parts in a factory, cases in a warehouse, airplanes in an airport, patients in a hospital emergency department, guests checking into a hotel, packages coming in and out of a distribution center. There again, you see the versatility of process simulation. So Witness moves parts through what Witness calls machines. Machines are things that add value. In a factory or a warehouse, they would be what you typically call machines. In a hospital emergency department, the machine might be the X-ray machine or a laboratory testing machine like the MRI. Buffers are where parts, like patients in a waiting room, or parts in a factory sitting in a buffer, as Witness calls it, queue up, as the British would say. Witness has a United Kingdom pedigree. Queue up for service. And these are some of the names of places where things can queue up, awaiting attention. Witness implements conveyors, which would typically be used in factories and warehouses. And Witness also has a concept called labor, which usually, especially in a factory, you would think of as the operator of a machine or the mechanic who comes to repair a machine when it malfunctions. And typically, labor is put in the model separately. It can be given a schedule of work, and machines request labor, and one machine may have higher priority than another for requesting the labor, and so forth. And a machine is perhaps the single most powerful and vital concept within a witness model after you bring the parts in and out. And at a machine, witness allows great power for specifying how does the machine get its input and at what rate, and does the machine need labor to do its work, or is it entirely automatic? How long does the work take? That shows a fixed number, but that can be variable. Where does the machine send its output? In what quantity and where to? These rules, well, you heard me mention the pull and the push, or the machine can be passive. The third common rule here is wait, and something else is taking the initiative. Also within witness, both labor and parts can travel along paths, and parts can travel using tracks and vehicles. The vehicle, as witness thinks of it, would likely be an AGV, automatic guided vehicle, or a tugger train, or a forklift, for example. And in witness, vehicles run along tracks. So in witness, these two concepts are inseparable. They always work together. Power and free systems have a separate modeling construct. And if someone branches out to continuous simulation, that might be like an oil refinery or a chemical plant, these constructs are available. Wait and pull and push are the fundamental input-output rules. And witness has a rich vocabulary of more elaborate rules to represent more complex process logic. So there's a great deal of power represented on this slide. The first two in each column are where a new modeler would start using witness. And here's a little snapshot of a witness model. The different colors show status of parts and labor and machines. For example, a machine can be busy, idle, off shift, or down. In other words, it's under repair. Or it can be starved. It's ready to work and no work is reaching it. And witness, like other high-power simulation software, provides, at no extra request, automatically provides all these valuable end-of-run statistics. So the witness software, it's well regarded worldwide. It can do either discrete event, which is primarily what we're talking here, or it can do continuous, like the oil refinery. Quick, easy model building. It can be integrated with spreadsheets and databases. The animation is very valuable for visualization and understanding and communicating results to management. And the statistics are reported automatically and can be exported to spreadsheets or statistical analysis packages for a deeper look. And witness now has, this is relatively new and an improvement, an experimenter that allows the modeler to create a variety of scenarios, like what if we had one slow machine, or what if we had two slow machines, or only one machine, but it's faster, we might pay more for the faster one. What if we had a crew of 3 or 4 or 5? What if there were 2 or 3 or 4 forklifts in our fleet of forklifts for parts movement and material handling? Well, quickly that becomes 2 by 3 by 2 by 4. You get a lot of alternatives. The witness experimenter, you click one button, they all run one after the other. The results you want are gathered and compared. You get, this is called a tornado. What's the most important? You get these line and pie charts, and you tell the experimenter to optimize based on whatever performance criterion is your criterion for optimization. And the experimenter will use a variety of optimization methods that originally came out of the PhD work in theoretical mathematics, and now they're inside the simulation software for you to use, and it will guide you toward the best of a great many alternatives. And Witness has a virtual reality, they call it the visionary render. As you can see from these, you just click one button on the mouse and the animation goes back and forth between 2D and 3D animation. And there's a runtime version. For example, some of our clients prefer that we build the model at PMC using our full-blooded version of Witness, and the client can then buy, at much less expense, a runtime version to run and examine the models that we build. And that's up to the client. Some clients want us to build the models. Other clients want us to teach them how to build the models so that if the client has enough modeling work, we help the client become self-sufficient and the client returns to us for occasional, particularly complex questions. So it's up to the client. And I'll turn it back over to our hostess, Claudia, now for questions and discussion.